Hi, in this video, I'm going to talk about the binary to decimal conversion as well as binary to octal and binary to hexadecimal. First, I will say about binary to decimal conversion. So for binary to decimal system conversion, so there are two parts. One is the integer part, another one is a fractional part. First, I will say about the integer part. For integer part, write down the binary number. Multiply each digit by 2 raised to the power of its position starting from 0, that is rightmost digit. Finally, add up the result of this multiplication. The sum is a decimal equivalent of the binary number. And for the fractional part, again write down the binary fraction. Multiply each digit by 2 raised to the negative power of its position starting from -1. The first digit after the decimal point we need to consider and add up the result of this multiplication. Whatever sum we got, that is a decimal equivalent of the binary fraction. Now we will see example. So this is the first example I am taking. So here what is the example is 1101. We are going to convert into decimal. So first we have to take the LSB part, that is the least significant part. So 1 into 2 to the power 0. We have to start to the power of 2 raised to the 2 to the power starts from 0. 1 into 2 to the power 0. Then second bit we have 0. So 0 into 2 to the power 1. Then next number is 1. So 1 into 2 to the power 2 plus the next number is 1. The 1 into 2 to the power 3. So 1 into 2 to the power 0 is 1. So we have written 1 here. So 0 into 2 to the power 1 is 0. Then 1 into 2 to the power 2. 2 to the power 2 is 4. So 1 into 4 is 4. Then 1 into 2 cube. So 2 cube is 8. So 1 into 8 is 8. So the answer is 13. So 8 plus 4 plus 0 plus 1. So answer is 13. Next, we are going to discuss about the binary to decimal fraction part. So fraction part, so this is our number 0.101. This is a number in binary format, so we need to convert into decimal. So here we need to apply the negative powers of 2. So 2 to the power -1, actually it is 1 by 2 to the power 1, so 1 by 2 actually. So it is 0.5. 2 to the power -2 means 1 by 4. It is 1.25. 2 to the power -3 means it is 1 by 8. So it is 0.125. Okay. So we got 3 digits. So we need to start from left. So after the decimal point, the first number. So 1 into 2 to the power -1. Next number is 0. 0 into 2 to the power -2. Next number is 1. So 1 into 2 to the power -3. We already calculated 1 by 2 is 0.5. So it is 0.5. So 0 into 0.25 is 0. Then 1 into 2 to the power -3 is 0.125. So 1 into 0.125 is 0.125. So the final answer is 0.625. So the base of this is 10 because it is a decimal. So the base is 10. Now we will see both integer part and fraction part. So mixed binary fraction. So 110.101. So this is a number in binary format. We are going to convert into decimal. First we convert the integer part 110. So as similar. So first one we need to take the LSB. So 0 into raise 2 to the power 2 to the power 0. First number 2 to the power 0. So then next number is 1. So 1 into 2 to the power 1 plus 1 into 2 to the power 2. So this is 4. Then this is 2 and 0 means 0 into 2 to the power 0 is 0. So the answer is 6. So fraction part 0.101. So we need to take the number after the point. Okay, after the decimal point we need to take the first number is 1. So 1 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. So this is 1 by 2 is 0.5. So 1 into 0.5 is 0.5. So 0 into 1 by 4. 1 by 4 is 0.25. So it is 0. When we are multiplying by 0, we get 0. So 1 by 8 is 0.125. So here 1 into 0.125 is 0.125. So what result we got is 0.625. So for the integer part, the decimal is 6. For fraction part, 0.625. So the answer is 6.625. Next, we are going to discuss about the binary to octal conversion. So to convert the binary into octal, we need to group the binary digits into sets of 3, starting from the right. That is the least significant bit. So to convert the binary to octal, group the binary digits into sets of 3, starting from the right. That is the least significant bit. So add leading zeros to the last group if it has fewer than 3 bits. Okay. So then replace each 3-bit group with its decimal equivalent, that is from 0 to 7. I'll repeat. To convert the binary to octal, group the binary digits into sets of 3, starting from the right. The least significant bit. Add leading zeros to the last group if it has fewer than 3 bits. Replace each 3-bit group with its decimal equivalent 0 to 7. So now we are taking the number, convert the binary number 110, 1110. Okay, so now what we have to do is group into 3s right to left. So right to left means first we are taking these 3 digits 110, next these 3 digits 101, next this 1. So it contains only 1 bit, so we add 2 zeros. Okay, as I have mentioned here, add leading zeros to the last group if it has fewer than 3 bits. It has only 1 bit, so we add 2 leading zeros here. Okay, so now this is 001 is 1 and 101 in binary in decimal is 5 and 110 decimal is 6. So answer is 156. Answer is 156. Okay, now we are going to discuss about with the decimal point. With the decimal point, how to convert. It is similar. So again, I am taking this number 10101.01. Again, first we are taking the decimal part, sorry, integer part. So 10101. So we are grouping into 3 bits. So first 101. This is 101. So that I have grouped here. Next one 10. It is fewer than 3 bits. So we need to add leading 0. How many leading 0 we have to add is 10. So 010. Okay, 010. And right side again it contains fewer than 3 bits. So we need to pad with a 0 at the end. Okay, so we need to pad the 0 at the end. So 010. Now we are going to convert each group into decimal. So 010 is 2, 101 is 5 and 010 is 2. Now what is the answer is 25.2. Answer is 25.2. Next we are going to discuss about binary to hexadecimal conversion. How to convert the binary number into hexadecimal, both integer part as well as fraction part. So to convert the binary to hexadecimal, split the binary string into groups of 4 bits from right to left. For binary to octal, we are taking 3 bits from right to left. For converting binary to hexadecimal, we need to split the binary string into groups of 4 bits from right to left. If it contains fewer than 4 bits, we need to pad with leading zeros. Okay, So as we know that in hexadecimal there is no 10, 11, 12, 13, 14, 15. Instead, it is represented as 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. Now we see an example how to convert a binary to hexadecimal. So this is an integer conversion. So integer part we are taking. So number is 1101 0110. So what's our number is 11010110. As I told, we need to group into 4 bits from right to left. Okay, right to left. So 0110, this first 4 bit we are grouping. Next 4 bit is 1101. Okay, so 1101 is actually, it is 13 in decimal. What is 1101 is 1101 is 13. So there is no 13 in hexadecimal, so 13 is represented as D. Next number is 0110. So 0110 is in decimal, it is 6. So what is the answer for this conversion is D6. Next one, we are going to do the fractional conversion. So for the fractional conversion, what is the number we are taking is 111011.111. Okay, this one we are going to convert into hexadecimal. Okay, binary to hexadecimal. So again, we need to group into 4 bits from decimal point outward. So here, first 4 bits 1011. Okay, 1011. Okay, and the next 2 numbers are 11. So we need to add 2 leading zeros. So answer for first one is 3. Next one 1011. So answer is 11. So there is no 11. So it is represented as B. Okay. Then 1110. So for fraction part, we need to pad 0 at the end. So 1110. So 1110 is 14. So 14 is represented as E in hexadecimal. So answer is 3B dot E. 3B dot E. This is actually the fractional conversion. Okay. We will see one more example. Suppose I have a number 1101 011. Assume that I am going to convert this number into hexadecimal. So what we need to do is we need to pad 4 bits at a time from right to left. So right to left means 0111 1101. So 0111 is this one. It is actually in decimal. It is actually 7. In decimal, it is actually 7, and 1101, it is actually 13. So 1101 is 13. So there is no 13 in hexadecimal. So it is represented as D. So answer is 7D. So this conversion, what answer we got is, we got answer as 7D. Similarly, if you have a fraction part, assume that I have a number 0.1101. Assume that I have like this number like this. This is a binary number. When we convert into hexadecimal, pad 4 bits at a time from the left after the decimal point. So first number is 1101. So 1101. So 1101 is 13. So 13 means it is actually D. Next we have only 2 bits. Okay, that is 01. So we need to pad 2 zeros at the right. 0100. So 0100. What is 0100 is 4. So answer is, how to write the answer is 0.0.D4. This is the answer for this particular example. Okay, this is actually binary to hexadecimal conversion, both decimal as both integer as well as fraction part.